notes are going to go through deriving what the cofunction identities are. Cofunctions are two trig functions that have the same ratio based on their fact that they have complementary angles. So first we're looking at this triangle ABC, and we want to complete our statement. Back from geometry, we learned that the three angles of our triangle always add up to 180 degrees. Right? And since we have a right triangle, which is angle C, we know that A and B have to add up to 90 degrees. These angles are what we call complementary angles. Okay, so the lowercase, we're going to use those lowercase letters to complete our ratios. So for the sine of A, here's angle A. We know our sine is opposite over hypotenuse, so we can see that this ratio will be A over C. Tangent of A, going back to angle A, tangent of A is opposite over adjacent. We know that that ratio is A over B. And cosecant, the reciprocal to sine is going to be C over A. Okay. We look at angle B. Angle B is up here on top. And we look at the cosine of angle B, adjacent over hypotenuse. We see that this ratio needs to be, or will be, A over C. Cotangent of B, again, for B over here, we have adjacent over opposite, which is A over B for cotangent. And finally, for secant, we have hypotenuse over adjacent, right, because cosine, and then, so that's going to be A over C. No, it's not. Hypotenuse is C. It's going to be C over A. Okay, so we have those three ratios, and what do you notice? Hopefully you see that the sine of A and the cosine of B create the same ratio, the same fraction. Same thing with tangent of A and cotangent of B. Different angle, but same ratio. And cosecant of A and secant of B, again, different angles, complementary angles, will generate the same ratio. So based on these results, what do we know? Well, we know that sine of A is equal to the cosine of B. Tangent of A is equal to the cotangent of B, and cosecant of A is equal to the secant of B. We know from before that the measure of angle A plus the measure of angle B equaled 90 degrees. Right? We said that before. If we solve this equation for B, what do we get? The measure of angle B ends up being 90 minus the measure of angle A. We get rid of this little symbol for the measure of the angle. We can substitute the fact that angle B, right, or just B, is equal to 90 minus A, just to simplify our notation. That expression is now going to replace what we have up on top. So the sine of A, we look here, up here, sine of A was equal to the cosine of B. We're going to take B and we're going to replace it with 90 minus A. So sine of A is equal to the cosine of 90 minus A. Tangent of A as a reciprocal function with cotangent, but now a cofunction as well, is equivalent to cotangent of 90 minus A. And finally, cosecant of A is equivalent to the secant of 90 minus A. So in all three of those, we replaced angle B with the expression 90 minus A. Does this work for all functions? Absolutely. Absolutely. So on our next page, in number 6, we're going to go through and write out all of our cofunctions. Let's rewrite these three. And from our identity sheet, we'll get the others. We have sine of A equals cosine 90 minus A, right? And the next one we had was tangent A is equal to cotangent 90 minus A. And finally, the secant of A is equal to the secant of 90 minus A. Those are the three we just derived. Well, what about our other three functions? What about cosine of A? Similar way, cosine of A, its cofunction is now sine of 90 minus A. Cotangent of A is equal to tangent of 90 minus A. And these are on your identity worksheet. And then last, secant of A is equal to the cosecant of 90 minus A, which would be angle B. So those are the three. We derived the first three on the left. The second three came right from our identity sheet. But instead of X, we have A. How could we revise this activity to now get the other three cofunction identities? Well, looking at, for angle B, for example, what if we said cosine of B? What's the cosine of B equal to? Well, it's equal to sine of 90 minus B. Or let's look at, we'll go down our list. Cotangent B is now equal to tangent of 90 minus B. And of course, let's do secant B, and that's equal to cosecant of 90 minus B. So what it doesn't matter what the angle is, we do have these equivalent cofunctions. So sine of B, would that of course be now cosine 90 minus B, right? Because that's really angle A. Sine of B is equal to the cosine of A. What was next? Tangent of B is then equal to the cotangent of 90 minus B. And finally, last but not least, cosecant of B would then equal secant of 90 minus B. So either way, our angles, we have complementary angles, our cofunctions will have the same ratio. So how does that apply when you actually put in some numbers? Well, cosine of 30, what's the complement to 30 degrees? It's 60 degrees, right? So therefore, this would equal the sine of 90 minus, well, our angle, I'll put A here, which is sine of 90 minus 30, which is the sine of 60. So that, as we know, is equal to the cosine of 30. Looking numerically at our values, we could also look at the fact that cosine of 30 is equal to square root of 3 over 2. Sine of 60, also square root of 3 over 2. So they are equivalent. We look at the numerical exact values for them. Okay, so how does this apply when we use, and we want to find exact values? Well, we're going to look at cofunctions. These are random numbers, 35 and 53. I'm sorry, 37 and 53. These numbers, we don't want to use our calculator to find them out, but we do know the fact that these values of 37 and 53 are complementary angles. So we can rewrite this in terms of another function. We can do this a couple ways. Secant of 90 minus 37 is equivalent to the cosecant of 37. And if we leave this one as the secant, we're going to leave secant 53. And we're going to subtract. We're going to leave tangent of 53. And I'm going to rewrite cotangent as its cofunction. Tangent's cofunction, or cotangent's cofunction is tangent of 90 minus 53. What is the value of 90 minus 37? That's 53. So now we have secant of 53 times the secant of 53 minus tangent 53 I wrote this wrong. This is 37. times tangent 53. What does this equal? This equals now squared terms. We have secant squared of 53 minus tangent squared of 53. What does that equal? That is your identity. Secant squared minus tangent squared. This comes out to be 1. Secant squared minus tangent squared is equivalent to 1. All right, number 10, we're going to verify that the left-hand side equals the right-hand side. Let's look at, okay, cosine 90 minus theta. Its cofunction is equal to the sine of theta times tangent, and we're going to try and get it equal to the other side. Well, sine of theta I'm going to keep, but then we're going to replace tangent with sine theta over cosine theta. Simplifying this together, multiplying, we get sine squared theta over cosine theta. Our identity, we want to get 1 minus cosine squared. You should again see that the identity for sine squared is 1 minus cosine squared theta. We're going to leave it over cosine theta, and that's exactly what we want. 1 minus cosine squared theta over cosine theta. And you're done. Okay? Your homework is to use your cofunctions, finding exact values, and simplifying and to verify some proofs like in number 10.